Yeah, hi, good afternoon, folks. Welcome back after the lunch. I understand that there could be some low energy, but I am hopeful that after this session, you'll feel excited and you'll learn something new from this session. I'm sorry I won't be able to come to video. I'm not feeling well since yesterday. I'm down under flu and fever, so please bear with me on that. So today's topic is software development practices for infrastructure code, as Sagar already briefed about it. Um, with invent of DevOps in last decade or so, like organizations have adopted IAC wherever possible. But while the scale grows, they could not scale the infrastructure code accordingly, and things started becoming chaotic. So over here in this talk or in this session, we'll learn how some of the software development practices, if we bring those to our infrastructure code, so that can help in handling infrastructure code at scale. So on the speaker side, again, Sagar has already introduced us. I'm Gopal. I am lead infrastructure consultant at ThoughtWorks, with over 5 years already in ThoughtWorks and over 18 years in industry. Monish.
Hi everyone, I'm Monish. I'm also a lead infrastructure consultant in ThoughtWorks. I have around 10 years of experience in infrastructure domain and cloud technologies.
Thank you. So today's agenda is uh, we'll we'll start with the introduction to infrastructure's code. What are some challenges usually organizations face when they scale up in IAC or their infrastructure span? And we have like identified some 8 9 such challenges that they face, and we'll be talking those one by one, which starts with duplication of code, inconsistency, traceability, and then others. We'll be talking about those in brief, and then also see um, how we can solve those problems with some good practices that we can borrow from software engineering practices. And here and there, wherever possible, we'll also try to come up with some examples using the leading infrastructure as code tool called Terraform. So before we jump to the next slide, I would like to have some pulse check. Um, so Naman, can you please help with that?
Yeah. We've launched a poll, so people can add their votes there.
Come on, people, show us some excitement, please. Answer the poll question.
I think we can close the poll and take
Move
the
on.
next. Okay. And the next one. Yeah, we can close this one also. Yeah, so good to see like majority of folks, they are familiar with Terraform, but majority have voted like they have not used some software development practices in Terraform or in other IAC tools. So I hope this session will be useful for you to like understand how these practices can be used with IAC, and how we can like benefit out of these practices in scaling our infrastructure code. So moving to next one. So what is infrastructure as code? Like I feel majority of you know, because you're already using Terraform or some other IAC tool. So still like infrastructure as code as per Red Hat is the managing and provisioning of infrastructure through code instead of through manual processes. And this is like a basic understanding that every one of us might be having, that if we are using some coding patterns. It could be DSL based, like declarative. It could be some programming languages we might be using, some libraries like Pulumi, Python. So all these things help in provisioning or creating infrastructure using code. So there are like many other uh, such definitions. I have listed a couple of them, like Wikipedia and Keef. So Keef is um, from ThoughtWorks. He has written a couple of books on infrastructure as code, and I think you'll be excited to hear from him towards the end of the today. So as we all know, IAC, we also have some understanding why IAC is important for any project or any organization. So starting with like time when we do all these infrastructure creation provisioning manually, it takes much longer than compared to code. So code can reduce the time multifolds, like from weeks to months to hours. Another thing that is very important or benefit from IAC is consistency. So once we have written the code, we can run it any number of times and we should expect similar results, however number of times we run it. So that brings consistency and we and like brings um, more accuracy towards the expectations. Next is collaboration. So when we are running setting up the infrastructure manually, then like less people are involved and they are following some sequential steps to get the infrastructure provision. But when we do it through code, like a lot of developers can contribute to the infrastructure code, and then like we have more scope to collaborate together and get a bigger infrastructure setup using code. Next is security. So since manual steps, like there is always scope of mistake, human errors when we are running things manually. When we do things in automated way through code, that brings an angle of quality checks, and we can validate the code against some lower environments, and once we are satisfied, then we can promote. So that way we can cater to any kind of security issues that we can see. Documentation, again, like a lot of Terraform infrastructure code uh, is like human readable, and we can understand what is intended out of the code, and it brings some level of documentation in itself. Like by default we get some documentation on what the code is intended for. And then last but not the least, system configuration. So we can manage multiple versions of configurations across multiple environments. So that way we can have segregation of how things should be set up for different environments. So I'm like running through initial slides a bit faster, considering that most of the people are familiar with IAC and its benefits. We'll spend more time on the individual problems that we'll see when we start adopting IAC and its scales. So we'll spend more time there with some examples. So next is a list of some popular IAC tools. So as I mentioned earlier, like we have seen good number of IAC tools came up in last 1 decade or so. So starting with like if we talk about cloud infrastructure, so first one in this is AWS CloudFormation. Then came Ansible, Terraform, and other cloud platforms like Azure and Google. They also came up with their own IAC tools, Azure's Resource Manager, and then Google had Cloud Deployment Manager. And then other tools again came like Pulumi, Crossplane, Azure Biceps, So this is not like the full exhaustive list. It covers some like more popular tools in the market. There could be many others which are providing IAC. Yeah, over to Monish to share some challenges that we face when code grows in IAC.
Everyone, as Gopal mentioned, like we have a lot of infrastructure as code tools, but we'll be mainly discussing about Terraform, being it cloud agnostic, and some of the challenges when we move across, when we scale our environments or when we scale our infrastructure with these tools, and how we can use our basic software development practices to resolve them or to make them go away. So some of these challenges are inconsistency across environments. For example, we have multiple environments, and we can see different environments having different type of configuration, which can easily be resolved using certain software development practices. We have potential duplication. We have like in Terraform, we can write lines and lines of code, which can become very large and complex, and there are ways that we can easily do it with a couple of lines of code with basic policy loops like for loops and ranges, etc. Then we have traceability. How traceable? How when we are making changes? How I'm going to trace? How I can roll back? How I can uh, move from one version to another, and those challenges. Then we have maintainability. How maintainable is my code is? What if I make changes on this code in the longer term? How we can maintain this? So then next challenge we have is scalability. Scalability, like how can scale I code? How can see how much scalable my code is, how you can make sure I'm following the best practices while discussing about scalability, while managing my infrastructure as a code, and keeping in mind that I can scale as much as possible. Then one of the challenges that we all think is security. How secure is my code? Is it secure enough? Am I confident enough that my code does not leak any data? Am I confident enough in my code that we are writing as an infrastructure? And then in parallel lines, do I have confidence that this code works how I want it to be, behaves the same way? Does it have all the features? Does it covers edge cases? And then that comes with lack of confidence. How can we bring trust in our code? Then other challenges are configuration drifts. Usually there are certain configurations that can be done manually that goes along with IAC. How we can make sure that these configurations changes are also capped as infrastructure as code, how we can maintain um, these configuration drifts over the time. And then is what if there is like, do I have infrastructure provisioning tool? Do we have any downtime for our changes? How we can make sure that we have zero downtime for our deployments? What are the best practices that we can use? These are some of the challenges that we have with infrastructure as code. And as our code grows, we have these 9 challenges that we have listed out, which we'll be discussing in much more details in the coming slides. So over to Gopal to take you for the few challenges and how we can easily resolve them.
Thank you, Manish. So jumping on to the first one, duplication of code. I'm assuming like most of you might have encountered this problem where when we start writing infrastructure code, like we have networking components, we have security components and other things, but as the requirement grows, a lot of time we end up copy pasting code here and there. For example, we started with 2 subnets and now we need 4 more. So rather than using some right refactoring methods, we end up copying the Terraform blocks or any block for the subnets, and then create 6 subnets. So that way we kind of replicate the same code uh, in 6 instances. Similar such instances that I have seen is security groups. So we have some security group rules. So rather using some recommended practices, we end up like copying the ingress or egress rules, and then end up having multiple rules in the code. Now, how it impacts is, for example, subnet or security group rule. Suppose we need to add some configuration to these subnets or these SGs. There is a risk we can skip few of them while adding those configurations. So, for example, if there are like some 10 such occurrences, we may end up like adding it to 8 and forget to add to other 2. So that way there is always a risk of missing or adding some configuration at some places and then not having it other places. So this is very common um challenge or problem that has been encountered when we start um, growing in the IAC world. So the solution that comes from software development world is DRY. That stands for don't repeat yourself. As per Robert Martin, duplication may be the root of all evil in software. So a lot of problems starts from duplication. We may end up having some security issues in the code. We may have some software misconfigurations, inconsistencies across environments, and a lot of these things originate with repetition or duplication of code. So we should avoid doing that, and there are multiple ways through which we can handle that. Over here, like I'm showing one example using Terraform, where it on the left side we have the code which has a lot of duplication. So if you see, we are creating subnets, and that subnet block is copied or duplicated 4 times. But on the right, rather than doing that, we are using a dynamic block provided by Terraform, where we are looping through a variable which defines the name and address prefix for the subnet, and it creates those number of subnets for us. So if in case we need to add another subnet, on the left, we have to add another subnet block and then hard code the name and address prefix. But on the right, we don't need to change the resource blocks. Rather, we can just update the variable subnet and add another element in that map. Sorry, in that list. So this is how like this is just one example. Terraform provides many other ways. So we can use count parameter. So count also helps in reducing duplication. So over here we are seeing for each. So there is for expression as well to loop around lists and maps. There is for string directive as well. So that helps in looping around maps within a string. So there are multiple implementations of for each expression as well, through which we can loop through multiple such input values and then create the corresponding Terraform or infrastructure code. There is another solution also, that is modules. So modules also help in resolving a lot of duplication of code, but we'll be covering Terraform modules in coming challenges as well. So another one is inconsistency across environments. As I mentioned earlier, this could be something that that could result from duplication of code. And there is even a possibility where like uh, we are not duplicating the entire code, but some code we are duplicating for environments because there are some mismatch, and then some code is common across environments. So those things further complicate the overall infrastructure management for different environments. So here we'll see like how we can reduce these inconsistencies across environments. So one solution that that Terraform offers is Terraform workspaces. So as you all know that Terraform manages state file for each Terraform execution, and uh, through Terraform workspace we can have state file for each environment maintained separately under the workspaces. And Terraform workspace also provides interpolation of workspace variables, so that we can have conditions to to name some variables, to have some configurations based on which environment it belongs to. So if you see that code block on the bottom right, so the count of AWS instances is conditioned based on the workspace it belongs to. So if it is a default workspace, then we want to spin up 3 instances, but if it is something else, then 1 instance. So this default could be production, and then for rest of the environments like QA or dev, it could be 1 instance. Same way, the name attribute that we are adding in tags. So over there, we are again we are using Terraform workspace as a value to identify which instance it is. So the instance name itself will have workspace as a prefix or suffix. And the next one is reusable modules in Terraform. So while talking about code duplication, I mentioned about reusable modules in Terraform. So in Terraform, like we can define our code in form of modules, where actual implementation is embedded in modules, and then we can reuse those modules in the actual code and pass on the information in form of variables to those modules to have the implementation accordingly. So for example, over here on the left, we have 2 modules. These are basically called to some module like VPC. On the second line, if you see dot module slash VPC, so there's a module called VPC, and we are calling it by passing 4 attributes or variables to it, which includes organization name, team, CIDR, and subnets. And then we are also creating Kubernetes cluster using EKS module. So this way, like we can reuse those modules in any for any environment, or even across multiple projects. So this brings a lot of reusability and scalability. So rather than writing the code to provision VPC or to provision EKS multiple times, it has been written once, and then it can be reused in multiple occurrences. One other benefit is if we are upgrading EKS version or some other modifications are done, so that can be rolled out in easier way across multiple usage, rather than going through each and every project separately. On the right, I'm showing a sample directory structure. This is not the only way, but yeah, one of the implementations of using modules. So towards the bottom, we have modules like app, DB, and VPC, and then another directory in parallel to modules is environments, where we are managing dev, QA, and prod environment. And then under that, we are storing Terraform files, which are calling the modules as shown in the left. And then we have TFR files, which defines all the variables required for that particular environment. So that way, the segregation across environments is done through the variables. Those are defined or provided to the modules as input, but the actual implementation or functionality is embedded in the modules itself. Moving on. So next is traceability. A lot of time when we jump onto version management for infrastructure code, we don't take versioning strategies for infrastructure code like that seriously. We may end up having just like a master or a main branch, and then all the code is going there and just pushing things, breaking things, and then fixing again. So rather than that, we should follow proper versioning strategies in IAC code, proper branching strategies, how we are having review process. So some of the examples are pull request based development, where you have feature branches where you add new code, and then on pull request there can be some quality checks, some other kind of checks that we'll see in this session later. And then once everything is green and everything is reviewed, it can be merged to master so that it can be promoted to higher environments. So that is one. Another thing that is very important, specifically when we are taking Terraform as an example, is pinning of versions. Um, as we saw that we can reuse modules, we can have providers for various cloud platforms, for other kind of infrastructure. So rather than always pointing to the latest, we should always pin the version that we want to use. That way we can ensure stability and traceability of how like what code is being run to set up a infrastructure. So if we are not doing that, if we are pointing everything to latest, then it is difficult to identify what version of code was actually run to set up something. If something is broken, it helps in trace and troubleshoot issues if we are pointing to the fixed versions. But yeah, pinning of versions bring its own challenge. That is, if we are pointing to latest always, then we are sure that we always get all kind of bug fixes, security fixes in our dependencies. But when we are pinning to some specific versions, we need a constant review of the new releases or versions being released from those providers or modules. And then based on the requirements, the bug fixes or security fixes, those are provided. We can upgrade the pinned version to the version that has been released. If we are writing our own modules, writing our own providers, then we should always has proper tagging and versioning mechanism in place so that consumers can follow the versioning pattern that we are providing. In Terraform, the new versions, they have .terraform.log.html that tracks the dependencies. So it is always a good practice to commit that file in version control so that everyone, like whoever is running the code or CI, everywhere the same versions of dependencies are consumed. So moving on, next is maintainability. So we know that like people join the team, they leave the team. So onboarding and offboarding happens time and again. And when code grows, it becomes difficult for new people to pick up things and start contributing. So it is always important to have the code in a form that it is maintainable, like people can easily learn and contribute to it. So if we see a design hypothesis over here, like if we have 10 features that takes X amount of time. Now, if you want to add 11th feature, then if we are not following proper design or we have poor design, then the time taken to add new feature is much higher compared to good design. If we are following good design patterns, good coding standards, then the amount of time to taken to add a new feature is much lesser. So initially, there is a possibility that you can get a lot of features developed faster if you are not following any practices. You are just adding code and adding new features. But that that curves though goes down as the code grows. But if we are following good design, maybe things are not as fast initially, but as code grows, it remains consistent even if we are adding features after like 100 features. Some of the uh, some of the sayings around clean code. So code is like humor. When you have to explain it, it's bad. So our code should be in such a way that anyone who is reading the code should be able to understand it, what it is intended for. Another saying that is quite common, that not even 10% of time code is consumed by computers. Though we feel that if we are writing the code, it is going to run on some CI/CD platform or somewhere by the computer. Uh, but majority of the time, around 90% of the time, the code is actually consumed by humans in form of reading it, updating it, writing it. So we should write code for the humans and not for the computers. There are other sayings. So yeah, a lot of important things, and all these sayings are actually emphasizing on why clean code is important when we are writing infrastructure as code. So though these practices are quite popular in development world, um, but somehow in infrastructure development, these things are either neglected or ignored, um, considering that infrastructure is different than software development. But when things scale, like these things are equally important in infrastructure world as well. So if we take example of Terraform, there are some code smells that we can find from the from reading the Terraform code, like code duplications that we have seen before, files growing to like to large files. We have like hundreds of thousands of lines in a single file. There is no proper naming convention in one file. The names are used in some form, and if we move to another file, then some other naming is used. Parameter lists are not reviewed, and parameters just grow based on new features being added. So rather than breaking it into multiple modules or multiple resources, the single module is overloaded with lots of parameters and lots of resources. Another is over engineering. Without having that problem today, we even tend to write code for future. So we feel that okay, these kind of things can come in future, and hence I should do this, I should do that. So over engineering can also be a kill. And how these code smells can be fixed. So duplication of code, as we've seen, like we can use modules, templates, and then there are some Terraform coding structures that we can use. For large files, we should do some refactoring. Again, we can use modules. We can break down the code into independent sections and different files. These files could be based on the type of resources we are provisioning, or we can club together the resources those are related to each other, so that we don't break the coupling and have loosely coupled resources in separate files. For improper naming, we should follow style guides. In recent time, like a lot of style guides have been released for Terraform and um, other IAC tools, so we can pick something that makes more sense to us. Um, for long parameter lists, we should set some sensible defaults around parameters in the style guide itself, like what should be our standards that we should follow. And over engineering, as we all know, like keep it simple, stupid, and you are not going to need it. So write only those things that we really need at that time, and maybe whatever you are thinking for future, keep it in the backlog, and if whenever it is required, you can write it at that time. So we saw some clean code challenges and some solutions how we can do it through Terraform. So here I just kind of summarized how these clean code practices can be done in Terraform. So some style guides are like the indentations, how we are going to name the variables, how we are going to use the blocks, how what all things we should keep in variable block, what all things we should keep in output block. So these are some examples of style guides. Um, Declaring variables in the right way, have proper validation blocks to ensure that right input values are given against the variables. Don't overuse locals, and try to use variables wherever possible. Use locals where you need to do some combinations or some computation around variables, and then extract out some other information from it. So these are some clean code practices that are possible with Terraform and can be used. Moving on to next item, scalability, and handing over to Monish to take up with other challenges that we see in IAC.
Thank you. Thanks, Gopal. So, as Gopal mentioned, like one of the design principles when we grow our infrastructure is like we create modules, we try to reduce the code that we are writing and use it across multiple environments, across multiple accounts. But one of the major challenges with scalability is how do I design those modules? What are the things that I have to consider while creating those modules? What is the boundary level, and how I can write good modules that can be utilized? So what we will be discussing next is how the solid principles, solid design and development practices can help us identify the modular approach and how we can break the code into multiple smaller modules and decrease the complexity. So we'll be using several solid principles for creating modules in Terraform. Some of those principles are, one of them is you should always have one source of truth. Like if your infrastructure object or infrastructure component is defined or is being created at one place, then we don't need to define it at multiple places. We don't need to create it at multiple places. So one source of truth for every component in infrastructure. Then we have shared single responsibility principle. Then while designing a module, we should always think that a module is always fixing one problem. For like a module for EKS cluster is creating EKS cluster and not doing all the other basic networking. So it's always have a specific set of reason uh, or principle for a module to have in place, like, and it's always have a single reason to change as well. So if you are changing your module, it's always for a single change. You do not combine multiple changes while changing your module. Okay. Another good practice while designing modules is to have dependency inversion. Like module should declare the dependencies. For example, if an RDS, while creating an RDS instance, dependencies that if I need to have VPC, I need to have subnet groups, I need to have DB parameter group. So all of these are dependencies, and it is better to call it out to while writing those modules and declare those dependency inside those modules. Then we have open or closed principle. While designing the module structure, it should be extensible. Like you can extend your module rather than modifying the modules on the need basis. For example, like if you are creating a module for deployment of microservice, for example, then it can be leveraged to create or deployment of similar microservice. But if you have to change this module for the second microservice, it's better to create for the second microservice a different module. Uh, so it's always follow the open or closed principle while designing your module structure. And one of the very important design principles around modular structure is it should have very low coupling and very high cohesion. What is meant by low coupling? Like if I have a module A and a module B, don't have too much dependencies on each other. They should be very loosely coupled, and they otherwise it's not a very good design. So always have resources in modules should be independent and very loosely coupled from modules in other environment for from other modules. However, the objects or the resources that we create within one module should have very high relationship, very high dependencies with each other. So that's about solid design principle. And then some of these design principles, while scalability that we have already discussed, like Gopal has already mentioned, like right for users and not for infrastructure experts, have some sensible defaults. Like you don't use a variable, have used variables as defaults, like you are using variable, but they can be defaulted. Stick to language conventions. Do not overdo things. Keep it simple. uh, Reduced code duplication, we have already discussed about it. Design so that you can destroy and create within few clicks. So again, some design principle that can help with scalability. Another challenge is security. How I can make sure that my code is secure, how I can make sure that I don't push something on my cloud and be vulnerable to attacks. And some of those security related configurations that can help us guide through Terraform as infrastructure as code can be seen in the next slide. Yeah. So some of the best practices while writing your IAC with Terraform, one of them is the remote files. Remote files are very important. They have a lot of information which can hamper our accounts, and so it's always a good idea to store the remote file securely. If you're in AWS, keep it on an S3 bucket with an encrypted source. So it's all, so make sure that you're not storing your remote file locally or on your version control system without any encryption in place or without any redaction in place. Again, on those similar lines, avoid storing secrets. For secret storage, try to use a secrets manager like Vault, AWS Secrets Manager. It's always a good idea to store secrets in those places rather than storing them directly within the state file. Make sure that you perform scans. Static scans goes very much in hand. We'll be discussing more about in the coming slide, like how we can prevent the misconfiguration, how various tooling can help us in detecting the configurations and misconfigurations. Execute Terraform programmatically. Don't do it on from your local machines. Try to come up with a CI/CD tool, be it any of these CI/CD, GitHub Actions, Jenkins, GoCD, but make sure that you have a pipeline in place that goes through all the checks and the central governments and security policies. Uh, and those are fitted very well inside our CI/CD tools. And then center have a central government's policy and security policy. All big organization does have that. Make sure that while writing the code, while pushing your code, you make sure that these you are within these boundaries and you're following the policies that are set up by the organization. Now, moving on, we look at some static code analysis tools, why it's important. Scanning tools provide a or it's an automated review. You just run it from your local or from your CI/CD, and it shows you where you are lacking. It reads your code and figure out what is missing in your code and what are the best practices that you have missed. It's similar to what in development practices we used to do: unit testing, functional testing, integration, and then end-to-end testing. It helps us to make sure that we have security, we are safe, and we are following the compliance and the organization standards. Sorry about a lack of time, so I'm just skipping through some of these. Some of these static code analysis tools are TF Security. It's a very good tool. You can integrate with your CI/CD pipeline. TF Linting is for formatting linting tool, similar to various linting tool that we have for other development frameworks like Java and Node.js. And then we have Terraform Validate, which uh, provide validates the syntax and semantics for consistency. So there are various tools that we can use. Then how do I gain confidence in my code, whatever infrastructure code I'm writing? So one of the ways to make sure that it happens is to do the automated testing. It is one of the very important piece in our infra while writing infrastructure as code, while designing your whole infrastructure, is to always test your code. And there are various ways you can test. There are various tools that you can use to test. Some of these tools we'll discuss in the next slides. Yeah, go. So the first one is the static analysis tools like Chekhov, TFSec can be used. They just analyze these tools that reads your code and then just without executing anything, without you know what are the security lapses are there in your code. They goes very much in hand and can provide results very quickly. And then we have incremental analysis of your code uh, where we are making any changes in our infrastructure, those changes are being detected again, and we do the analysis of, we do the testing, or uh, we do run them against our organization policies whenever the new code is added or whenever the new feature is being created. Then we have functional test, like where we are writing test cases. We are making sure that these test cases run. We have a sandbox environment where we create this infrastructure. We test uh, all the edge cases, where we test whether what we are creating is actually working, and then destroy that sandbox infrastructure. So there are various tools which can help us leverage these functional test cases, and can be done in an automated way. So this is the whole life cycle, like how we can test our Terraform code. We create a new branch from the main branch, make whatever changes we are working on, make sure that we have a PR in place. Whenever we are putting the code, then the static analysis being run through a CI/CD. We apply the code in the sandbox environment, for which various tools like TerraTest, Kitchen Terraform can be used. And then finally, we merge to main branch, and then we update it on QA and production environments, and finally it's get promoted. So this is how we can use the whole life cycle, CI/CD life cycle, to test and deploy our code security and gain confidence in whatever we are deploying. So yeah. Then next we have is configuration drifts, which is a challenge. Sometimes our configuration, whatever we are writing as infrastructure as code, does not match. And there are three kinds of drifts or difference from the actual state. One is emergent drift. Sometimes we do make changes directly from the console. And then what we do is, like in the emergency situation, we just directly make the changes on the console. So how we can make sure that we overcome those? So for that, we can, like if it's a non-prod environment, we can destroy whatever we did from the console and write the IEC code. Or if it's a production code, we can use Terraform import commands to make sure where we are on place. Then we have pseudo drift, where there are changes in the list style or the subnet mappings, and some of the so Terraform show can help us to overcome those pseudo drifts. And then finally, there is introduced drift, where we have provisioned something new, directly from console, and we can use Terraform import to make sure that we are on managing the Terraform state drift in a better way. Yeah. And then last one is downtime for rolling changes. Ideally, we all want our infrastructure to have zero deployment downtime, and there to have those zero deployment downtime, we can use certain practices that can help us in rolling out changes with minimal downtime or even zero downtime. And there are various practices in place. Some of those practices in Terraform are like create before destroy, like you create your infrastructure before destroying, and helps to mention that your application is running with all the passing the health checks, and then your old instances goes down. You perform blue green deployments. For example, you have a service running, uh, And then there is a load balancer, which is right now on version 1, and then there is you deploy version 2 of that, and you map your load balancer to version 2. So that's also one way, which is having very minimal or very no downtime at all, to have blue green deployment, in which you have two applications running at the same time, but one of them is performing the live traffic and the another one sits idle. And then you can also perform like combining Terraform with another all other automation tools like Ansible, which can help us to make sure that we are ready within no time. We are able to deploy within no downtime, and we are good. And this can be achieved combining Terraform with other provisioning tools like Ansible, where we can write playbooks. This is just a simple structure of how we can do so the whole CI/CD. We have a development environment, we have test, stage, prod. Initially, we start taking the main branch, we create a PR, we do the code review, we run static analysis of our code, we run validate, then we run some functional test using Kitchen and Terraform, and finally everything looks good. We merge into master and deploy on the development environment. On the dev environment, we again run some integration test cases where, and then finally we deploy to test environments. And in the test environments, we actually are running maybe end-to-end test cases. But this is where we run end-to-end test cases, where we see that our whole end-to-end functionality is good. And then finally, once everything is green, we move to the staging environment, where we can leverage the same same structure. However, here this is where we finalize, like everything looks good. We get the sign off from the various stakeholders, and finally move everything to the production environment. This helps us gain in confidence. So that's about it. That's about the challenges that we have in infrastructure as code tools, and how we can use design practices to overcome them.
Yeah.